Welcome to Naresh IT Technologies. This is Ramachandra from NIT. Today I am going to be talking about what is platform independency and how Java became a platform independency language. And in the meanwhile of explanation about platform independency, I am going to be talking about source code, bytecode, and as well as executable code. Really all these codes are comes under platform independent or not. In the meanwhile, I am going to be highlighting concept like JVM, and I am talking few things related to the JVM. After that, finally I am concluding about why Java is a platform independent language in the market. Sure. Now let me start with concept like source code. If you are writing any code under any language like C, C++, Java, .NET, that code we can call as source code. If you are writing any code under the Java, that code we can call as what? Source code. So if you want to write any source code in Java language, we require editors, text editors like Notepad, Edit+, Eclipse, NetBeans, these type of editors we required. At starting level, we are always writing the programs at in the Notepad. So here first let me take one Notepad. This is one Notepad. In this Notepad I am writing one small program, class demo and class A, and I am taking one more class like B. In this Notepad I am taking three classes like demo, A and B. After taking this class, after writing this program, if you want to execute the program under the machine, first we need to save this. So here I am giving one name like for saving purpose I am giving one name like first demo.java. This is what? File name of source code. This is file name of source code. Now here once we saving the file, definitely that will be saved in where? Our machine. Machine means here in the hard disk. Now let me save this file. So once we save this file is going to be saved in hard disk. This is what? Hard disk, or we can also call it as what here? Secondary memory. Now observe here, in this secondary memory the file is as it is will be placed, nothing but save. Now this is what exactly? Source code. If you want to execute this source code under the machine, definitely this source code is not understood by the machine. First we need to converting this source code to what? Executable code. Now I have different types of operating system. Here I have one operating system like Windows. Here I have one more machine and it contains what? One more operating system like Linux. And also I am taking one more machine, and in that machine I have one more operating system like Mac OS, and after that I have one more operating system. In this system, one more machine, in this system I placed or installed Solaris operating system. Now I want to execute this source code in where? In the machine code. If you want to execute the source code in the machine code, first we need to convert this source code to executable code. So if you want to execute the source code to, if you want to convert the source code to executable code, definitely we required some programs. Those programs we can call as translators. Those programs we can call as what here? Translators. Now Java mainly provides two types of translators. One is compiler, another one is what? JVM. Java provides two types of translators. One is compiler, another one is what? JVM. Now, among these two, we are choosing first compiler. Why we are choosing the compiler first? The reason is compiler having the capability to understand source code. This is what here, one operating system I assume, this is Windows operating system. In this Windows operating system I am writing what here? Source code. Okay, now first I am hand over the source code to whom? Compiler. Now we have two translators, one is compiler, another one is JVM. Now one is compiler, another one is JVM. So compiler having the capability to understand source code. Now if you want to communicating with the compiler, definitely we required one more program. That program we can call as what? Java C. If you want to communicating with the compiler, definitely we required one more program. That program name is what? Java C. We can call as what? Program, and also we can call as what? Command, and also we can call as what? Development tool, and also we can call as what? Binary file, and also we can call as what? Binary file. With the help of this tool, we can able to start the compiler program. Now Java C is communicating with compiler. Now compiler is reading source code. Where exactly this source code available? Within the one file name, that is what? firstdemo.java. firstdemo.java. This is what? File name. Now compiler is able to communicate, will read that name, and again compiler is going to be communicating with hard disk. Now assume I saved file name is what? firstdemo.java, but here I am writing what? firstdemo1.java. Then what happened? Compiler will check whether the firstdemo1.java is available in the hard disk or not. If not, simply it will giving file not found error. Simply it will giving file not found error. If available, yes, in this particular time I am writing what? firstdemo.java. Now what happened? Compiler will communicating with the hard disk, and within the hard disk some particular current working directory. What is current working directory we will see in coming videos. Now compiler will fetch this firstdemo.java from command prompt, nothing but hard disk to primary memory. Now compiler will load this firstdemo.java file from secondary memory to primary memory. .java file loading from secondary memory to primary memory. Now after loading, meanwhile of loading, compiler is going to be check whether the source code comes under Java grammar rule or not. Whatever the code we are developing syntactically correct or not. If not, compiler will giving what? Appropriate errors. Compiler will giving appropriate error messages. Those we can call as compile time errors. Yes, .java file is existed, our source code is well designed. Then what happened? That source code will be converted into bytecode. Now compiler will generate bytecode. This code we can also call as JVM understandable code. JVM understandable code, as well as we can also call as intermediate code. So like this, different types of vocabulary we have related to the bytecode. Now this bytecode is generated. So if you want to save the source code, we have a file name. If you want to save the bytecode, what we required, again we have one more file. Who will created that file? Automatically compiler is going to be created that file. and that file extension is always what? Dot class file. Always what? Dot class file. Now every file name, every file having one name. Here I am giving the first demo. Now what type of name taken by the compiler in this particular area? Whatever the names we are giving, whatever the class names we are writing, those class names are taking as a dot class file names. Now maybe here demo is one class, A is one class, B is one class. These are what? Class names. Now these class names will be taking as a file names. So here we have demo A, B, three classes we have. Among these class names, which one is going to be highlighted by the compiler? Not any one here. Every compiler is always taking what here? Three class names. Now what is the meaning of that? Nothing but demo dot class. One more class name, what is that? A dot class. One more class is what is that? B dot class. So again, each and every class have its own bytecode. Not only creating dot class file, after creating all these dot class file, again placed into where? Hard disk. By whom? Compiler. Now demo dot class, after that A dot class, after that B dot class. Now if you want to execute any program under the mission, we required executable code. Now what type of code do we have up to now? Bytecode. But what type of code we required? Executable code. Then what should I do? We need to converting from this bytecode to executable code. How we can convert this bytecode to executable code? With the help of one more translator, that is what here? JVM. Now compiler will convert it into source code to bytecode. This concept we can call as, this phase we can call as what? Compilation phase. So in the compilation phase, source code will be converted into bytecode. Now if you want to execute the program under the mission, what type of code we required? Executable code. But up to now in our hand, what type of code we have? Bytecode. Then what should I do? I need to converting this bytecode to executable code. If you want to converting bytecode to executable code, definitely we required one more translator, that is what? JVM. Bytecode. Now we have bytecode. Bytecode is platform independent code. Bytecode is platform independent code. This bytecode can easily converted into Windows operating system understandable code, as well as Linux, as well as Mac OS and Solaris. So this is a platform independent code. This is means what? Bytecode. Now we should converting from bytecode to what type of code? Executable code. So for that purpose we required one more translator like JVM. Now let me take a JVM. This is what? A JVM. How to communicating with the JVM software? With the help of Java. Again I told you, Java is what? A program or command or development tool or binary file. Here Java is also same thing. Now Java is going to be communicating with the JVM. JVM is going to be communicating with bytecode files. Here bytecode files are what here? The file which is contains what? Bytecode. That is called bytecode files. Now demo dot class, A dot class, B dot class. Here we have three dot classes. We need to write any one dot class name here. Let me take one class like demo. Now JVM will communicating with demo dot class. After that it will communicating with hard disk. Whether if the given file is not existed, if the given file is not existed, then it will giving one exception. It will giving one error like no class def found error. Up to 1.6 we will get one error like no class def found error. Up to 1.6. From 1.7 we are getting one error like could not load main class, could not find or load main class demo. It will giving that type of error message. From 1.7 onwards the error message is changed. Now Once a demo.class file is existed, then demo.class file is going to be loading. Demo.class file is going to be loading from where to where? Secondary memory to primary memory. Here dot class file loading. Dot class file loading from where to where? From secondary memory to primary memory. Now, so demo.class file is coming. So here observe here, who will loading demo.class file? Internally what happened? And is JVM directly communicating with the dot class file or not? Is there any other component available or not? That we will see in coming videos. But here what happened? Demo.class file is loaded from secondary memory to primary memory. After that, this demo.class file contains what? Bytecode. This bytecode will be converted into what here? Executable code, and finally that bytecode will be executed. That bytecode means executable code will be executing under all operating system, and we will get what here? Same output. Assume I am developing source code under the Windows. The same source code finally executing under all operating system. So what is the meaning of platform independency? Developing one application under one operating system and compiled it, executing the same dot class file within the different operating system, we can call as platform independency. Here one more important point. Now one more important point is how JVM will converting this bytecode to executable code. Is one JVM is sufficient to executing to converting from bytecode to executable code? No, one JVM is not sufficient. We required multiple JVMs. One JVM can able to understand only one operating system. For example, I want to execute dot class file within the Windows operating system. We required JVM for Windows. If you want to execute the application under the Linux, we required JVM for Linux. If you want to execute the application under the Mac OS, we required JVM for Mac OS as well as JVM for Solaris. JVM for Windows can understand this bytecode. After understanding this bytecode, it will convert it into Windows operating system understandable bytecode, executable code. Now JVM for Linux, it will understand this bytecode, and after that it will convert it into Linux operating system understandable executable code. So one JVM is strictly bound with what? One operating system. One JVM is not understanding multiple operating systems. So one JVM is strictly bound with one operating system. That means JVM is a platform dependent component. It is not a platform independent. JVM is a pure platform dependent component. Now here we need to talk about especially 5 things. One is about source code, another one is bytecode, another one is executable code, and the fourth one is about JVM, and the fifth one is about Java software, and the sixth one is Java software application. Now first point, so are these 1, 2 and as well as 3, 4, 5, 6, all these are platform independent or dependent? So let me start with concept like source code. Source code is platform independent. If you want to develop any one program under the Java, that program syntax is same for all operating systems. Same for all operating system. Same for all means there is no dependency. That is comes under what here? Independency. Source code is platform independency. Now bytecode is what? Platform independency code. The reason is whatever the code generated by the compiler, that code can be suitable for all operating system. That is comes under what here? Platform independency. So bytecode is platform independent. Now come to the executable code. Executable code is what? Platform dependent code, nothing but platform specific code. See, Windows executable code understanding Windows operating system only. If you want to a JVM executing bytecode to executable code under the Linux, that code only working under the Linux. So here executable code is specific code, one operating system executable code, not same as other operating system. That's why this is platform dependent. Source code is platform independent, bytecode is platform independent, and executable code is platform dependent or specific. Now come to the JVM. JVM is also what? Platform dependent. Why? One JVM is not suitable for all operating system. One JVM is must and should be suitable for one operating system. Nothing but one JVM is tightly coupled with one operating system. That's why JVM we can call as platform dependent. Now come to the Java software. Most of the people telling like Java is a platform independent and independent. Really Java software platform independent? No, that is platform dependent. The reason is we have different softwares for Windows, for Linux, for macOS, for Solaris. One Java software not suitable for all operating system. We required OS suitable operating system. OS suitable operating system means if you want to execute, if you want to develop any application under the Windows, we required Windows supported Java software. If you want to execute the program under the Linux, we required Linux supported Java software. So one Java software is not suitable for all operating system. One Java software only suitable for one operating system. Again, Java software is tightly coupled with platform, nothing but operating system. So this is Java software is what here? Platform dependent. Now comes to the Java software application. Java software application means the application or project which is developed under the Java language. That application is what? Platform independency. So most of the people speaks like a platform independency. Independency means we are talking that concept through application wise, not software wise, through only application wise. Java software application is platform independent. The reason is here Java application I am developing under what type of operating system? Windows. The same application can able to executing under what here? Windows, Linux, Mac and Solaris. So this type of operations we can call as what here? Platform independency. Now let me give a quick review. Source code platform independency, bytecode platform independency, executable code platform specific or platform dependent, and JVM platform dependent, and Java software platform dependent, and Java software application is platform independent. We are always talks about Java is a platform independency means we are talking that concept related to application wise, not software wise. This is what exactly platform independency concept under the Java. And that's all for this video. Again we will see some more important concepts in coming videos. Thank you.